According to the Canadian Renewable Energy Association, Canada's solar energy capacity, utility scale, and on-site grew 92% from 2019 to 2024. Since 2020, Canada saw nearly 2 gigawatts of new utility scale solar and over 600 megawatts of new on-site solar. So, as we close out our special theme week on alternative energies, brought to you in partnership with test and measurement leader Fluke, let's turn our attention to troubleshooting common solar PV problems so that we can keep those installations up and running. Will White is a seasoned professional in the renewable energy sector with 2 decades of experience spanning installation, sales, design, project management, curriculum development, and teaching. Since 22, Will has served as Senior Application Specialist at Fluke. His technical area of focus is distributed energy resources, including energy storage, electric vehicle supply equipment, and photovoltaic systems of all scales. And Will joins me today to discuss troubleshooting tips for the top 3 areas of concern in solar PV installations: ground faults, modules, and inverters. Welcome, Will, and thanks for being here.
Hey, how's it going? Thanks for having me.
Now, Will, let's dive right into the number one area of concern that you had identified, and that's ground faults.
Yeah.
So maybe you can just go over what are some of the common causes of ground faults?
Yeah, ground faults. So let's start with the basics of what a ground fault is. It's a connection between a current carrying conductor and a grounded metal part that shouldn't be there. So DC, positive or negative, got trapped between a module frame and a racking is a good example. A lot of the kind of common source of ground faults leads all back to installation technique and installation quality. So making sure that you have a good quality wiring and wire management on a job will reduce ground faults because that typically is a lot of the cause of it. It's wire rubbing up against something because it was run over the sharp edge of a piece of racking, and over time that insulation wore away, causing a ground fault. Pretty common for solar installations.
Something like that might be obvious on a very small installation, but sometimes we might be looking at something utility scale. Are there any telltale signs of ground fault problems?
It all starts with the inverter. Every modern inverter has a ground fault detection and interruption device built right into the inverter, and that's everything from a micro inverter on the residential scale up to giant utility scale inverters. So inverter is typically going to be your first sign. When it senses that ground fault, the inverter is going to shut off, so your system's not producing, or at least that section of the system. So that's going to be pretty obvious. From there, you can do things like visual inspection. Sometimes ground faults will be arcing, so you'll see the damage from arcing and the fire hazard. So you'll see browning in the backside of the module, things like that. But really, the inverter is going to be the leading indicator of whether a ground fault's present.
So that's a pretty telltale sign. If the system is down and not producing energy, then
Yeah, it's pretty obvious, and it's you're going to get alarms usually, whether it's a residential scale system will often email the homeowner if the system is not operating, and of the larger commercial and utility scale systems are being actively monitored. So they'll know as soon as that inverter goes down, they'll issue a maintenance ticket for that, and then the O&M technicians will go out and start troubleshooting that.
now outside of the inverter going down, if a technician is assembling and building this solar plant, how
Yep.
does that technician verify that the new system is installed well and resistant to ground faults?
So, like I said, the installation quality is going to lead to higher quality will lead to less ground faults. So, making sure that they're paying real close attention to how they do the wire management. Wire management, It's a simple thing to do, but it's hard to do it really well so that it's resistant to ground faults. Making sure wiring's not routed over sharp edges, making sure everything's supported properly, has a little bit of give and take so it can expand and contract without rubbing against sharp edges, but at the same time is well affixed so wire's not hanging down loose. Paying attention to things when you're pulling wire through conduit, that you're not damaging the insulation there. Once you get into the commissioning phase, there's testing we can do. So we can do insulation resistance testing, which is essentially like pressure testing the wiring. It's making sure that we didn't damage that insulation during the installation process. So, simple things like that, just really paying attention and doing a good detailed job of that wire management can go a long way, especially when you get out to years, 5, 10, 15, 20. Good installation techniques on the front end are going to make it much easier to maintain on the back end.
It's the old pay now or pay later, right?
Absolutely, and that's definitely true in the solar industry. And part of the problem we have is that the installation crews want to get this done as fast as possible, get on to the next thing. But you need to really be thinking about how this is going to be maintained in the long run. And simple things up front can make it much easier for the operations and maintenance team in the back end.
Well, speaking of maintenance, so we just finished talking about a new installation, but let's say a technician is now called in to troubleshoot an existing installation. So how does that technician who's troubleshooting an existing installation check for ground faults?
There's a couple ways we can do it. Again, the inverter is going to tell us if there's a ground fault in many cases. There are some cases where the ground fault's operating at a low level and the inverter doesn't quite catch that. We can use voltage testing. That's the common way of finding ground faults in string of solar modules. So testing from the positive to ground, negative to ground, seeing what voltage is there, and then you can do some basic math to figure out where the ground fault is located approximately. Insulation resistance testing, we can do that to find the circuit that has the low insulation resistance to ground. That'll indicate a ground fault. Won't tell us where it's located, but it'll give you the circuit that it's in at least. And then Fluke, we have a new tool that's going to be coming out in the next month or two, the GFL 1500. It's specifically designed for locating ground faults. It's a ground fault locator. It's specifically designed for the solar industry. And that's a new technology that hasn't been used in the industry to this point. So it's going to be able to both identify when you have a ground fault. It's going to do that voltage testing for you. It's going to be able to tell you approximately where in the circuit of solar modules the fault is. But then it's also got some features that will allow you to very quickly trace where that fault is located. So beyond just saying, yes, we have a fault, we know about where it is, it will have functions that allow us to go out into the field with a receiver or a current clamp and very quickly identify the exact location of where the fault is, which has been really challenging in the industry up until now.
Very nice one-stop shopping for the ground
Yeah.
faults.
Yeah. It adds a bunch of features into one unit, which will make it hopefully very easy for technicians to not just diagnose, but locate and then quickly repair and then get that section of the array back up and running. It's been very common in the industry, especially in the larger scale systems, that when they identify that circuit that has the ground fault, they just take that offline. Just to get the inverter back up and running, because the time to locate the actual fault and repair it, it takes so long that the labor to do that just isn't worth it. But with this new tool, hopefully that will make it so much faster that they'll just be able to quickly find where it is, fix it, get that circuit back online so the whole system can be operating properly.
Right, get things back up and running as quickly as possible. Excellent. You say about what was that, 2 months time?
Yeah, it should be out in September. We'll have it at the RE Plus show in Vegas this year. Yep,
Nice, the GFL 1500. All right, keep our eyes open for that.
for
Uh,
sure.
Now, next, Will, you identified we've covered ground faults. Now, the number two area of concern that you've identified is the photovoltaic modules themselves as a
Yep.
possible area of concern in a solar power installation. Now, I'm curious, when should an installer check whether the module will actually work or is working as it should?
Most people, when they're doing an installation, will check modules, check open circuit voltage just to make sure that they've got voltage on the module. That's a pretty common test before you install the module. Once the modules are installed, but before the system is turned on at commissioning, it's very common to do a series of tests. You can do voltage testing, again, to make sure you have the proper voltage in the string of modules. Polarity testing is really important, making sure they wired everything right. Insulation resistance testing as well to make sure that that insulation hasn't been compromised during installation. And then IV curve tracing is a test specific to solar modules. This is testing open circuit voltage to short circuit current, uh, taking different measurements between those 2 points, and then it can create a graph. And that's really the only way to get the true picture of how a module or string of modules is operating. It can show you things that you wouldn't see with just voltage and current testing. So IV curve testing is an excellent tool to use to diagnose those problems with modules. Now, once you've got the system up and running, thermal imaging, especially aerial thermography, is really helpful. Large arrays, you can send a drone out. The drone takes thermal pictures. You can identify problems with the array very quickly. Typically, they take the pictures, they put it into a processing software. It gives you a list of potential problems, and then you go out into the field and do that further diagnostic testing with the tests we already talked about.
Let me go back a little bit and ask you, similar to the ground faults, what are the telltale signs of an
Mm.
underperforming module?
Yeah, usually systems will have a monitoring platform, so we can see, and this is, we're going to talk about inverters in a minute, but this will work for both modules and inverters. We can see if it's not producing up to our expectations, and it'll give us kind of an idea of at least, are we producing what it should be or not? From there, we can do the further diagnosing. The aerial thermography, again, is a great way to look at the array and see if there's problems with our modules. Honestly, visual inspection is a great way. Getting out into the array, walking around, looking to see if there's damage. It's more challenging to do in those larger systems just because of the labor cost of that. But it can be a good way just to get out and see if there's systematic problems with the system. From there, we can do all kinds of other sorts of diagnostic testing, like the voltage and current testing, insulation resistance, IV curve testing, handheld thermography, looking for maybe problems with connectors between modules, things like that.
See, Will, I love that we're having this conversation because if you look at a field of solar panels, a large installation, you
Yeah.
know, a person, I suppose, could be forgiven, walking by, driving by, and going, "Oh, that looks so simple. You just put a couple of racks in the ground, you hang a bunch of panels, and boom, you're producing electricity." But there's actually more to it than that.
Yeah, there is, and it's we made kind of a mistake early on in the industry. I've been in solar for almost 20 years now, and back in the day, especially on the residential systems, we used to say, "Oh yeah, you get it, put it up on the roof, leave it there, and it's great for 20 or 30 years." And yeah, it turns out that's not the case. It does need some maintenance. Residential less so maybe than the larger scale systems, but yeah, it's a piece of equipment. It needs to be maintained properly to ensure that it's going to produce the return for the owner that we, forecasted at the beginning.
Very good. Now, rounding out our top three list of common areas of concern in solar PV installations, and
Yep.
you've name dropped in the first two as well. Now we get to the inverters, so let's
Sure.
move over to them. Now, as before, with the first two, what are the telltale signs of inverter issues?
Yeah, and inverters often have error codes. So they're going to tell you if something's wrong. The monitoring platform is going to tell you if something's wrong. We can also look at the monitoring again to see what's the actual performance compared to what our expected performance was. Um, those are going to be our kind of leading indicators. With that information, especially with the error codes from the inverters, they'll give us an indication of what the source of that problem is, and then we can go in and do further testing. Same tests with modules. We can do voltage and current testing. Usually insulation resistance testing would be on the circuits either coming into or going out of the inverter. On the AC side, we can look at things like power quality. It has a huge impact on our inverters. And in my experience, when we're often having power quality issues, it's not necessarily coming from the inverter, it's issues with the utility that's impacting the output of the inverter. So oftentimes we're using the power quality instruments to prove to the utility that, hey, we're having a problem and it's coming from your end. So we're doing a lot of testing like that. Thermal imaging. Another great test with inverters and any electrical equipment. We can look at terminals. We can see if terminals are overheating. Maybe there's a loose connection that's heating up, and we can see that with a thermal image before it becomes a catastrophic failure, which is really key. On the flip side, we can also see things like fuse holders that are operating at a lower temperature than other fuse holders that are under the same condition. And that could indicate things like the fuse is blown, or maybe there's a break in the circuit out in the array that we would need to address. But we can see all kinds of things with thermal imaging that you wouldn't be able to see with just a visual inspection.
Hmm. I think you've touched on a few of these, but are there any ways, or do you have a sort of go-to list for verifying that the inverter itself is functioning as it should? Because it could be delivering error codes, but how do we know that device is actually working right and delivering the
Yeah.
proper error codes?
Yeah, it's getting on site and getting into the equipment and using the different diagnostic tools to verify is really what we do. But the go-to is going to be the data monitoring system and seeing is this inverter actually putting out the amount of power and energy that we expect it to. Another common problem, and this is kind of it can be inverter related or can be kind of a side effect, but is data communications. We don't think about that in solar, but there's a lot of data that comes from the system, especially utility scale systems, where we have multiple inverters across the system. They're producing all sorts of information. That information has to go to the data acquisition system. We also have weather monitoring stations, sometimes multiple weather stations. So we've got data coming from that as well. And we're going across long distances. So we've got a combination of both copper wiring, we've got fiber, and we need to maintain those as well. So of course, Fluke has a whole suite of tools for networking applications. So we can see how that's working with the system as well.
And that's why you're here speaking with us.
Yeah. It's interesting. Fluke is a unique company in the test and measurement industry. We have a tool for essentially every test that needs to be done in the solar industry. So everything from the multimeters and clamp meters for testing voltage and current, insulation resistance testers, power quality, networking tools, thermal imaging, and then the solar specific tools like the IV curve tracers and now the ground fault locator. So yeah, we've got pretty much a solution for everything.
Now, before we wrap things up, Will, we talked about the top three concerns that you've seen with your many years in the solar PV industry. So we covered ground faults, we covered the modules, we covered those inverters that it just based on our conversation play such an important role in everything else.
Sure.
Now, are there any other best practices that you would recommend to installation or maintenance technicians, just as part of our wrap up?
Well, we talked about wire management. I mean, that's always my go-to when I'm doing a system inspection is what's the wire management look like? If that looks good, typically the rest of the install is good. But really, you're taking the time on the front end to do quality work makes it so much easier on the operations and maintenance side to ensure that the system is going to be operating for a long time. Beyond that, having the proper number of operations and maintenance professionals there to maintain the system and making sure that they have the adequate training and the tools that they need to be able to do their job efficiently and safely. And that's something that we focus on here at Fluke, making sure that our tools are designed and tested to ensure that technicians are going to be able to do their job safely, but go home at the end of the day. I mean, we always want to make sure that our technicians are going home to their families and being safe on the site.
That's an excellent way to close things out with that safety message.
Yeah.
Yes, we want efficiency. Yes, we want our installations up and running, but we want our technicians going home safe at the end of
Yeah.
the day too. All right. Well, Will, thank you so much for coming on to talk about these top three issues that you've seen in solar PV installations. And thank you, Fluke, for partnering with us for Alternative Energies Week, partnering with Electrical Business Magazine.